Greetings. We're going to be talking about using abbreviated truth tables. You've certainly already been working on this, but I thought I'd give this to you afterwards as a kind of a summary and hopefully a useful review. When you normally look at a truth table, you see lots and lots of rows and lots of values. And it may occur to you to wonder, why do we need to do all that? Well, there are valuable things in it. There's lots that you can learn from it, and we'll be learning more from it later. However, when you're looking for checking validity or invalidity, well, the key to finding an invalid argument is this. It needs to be that all the premises are true, but the conclusion is false. Putting that in terms of truth tables, it means finding a line on the truth table where all the premises are true, but the conclusion is false. But why find all the other lines? There's an idea there. Why not start there? Why not start with finding one line with true premises and a false conclusion instead of all the other lines? That's a good idea. If you can think this way, it'll enable you to make quicker progress and to go through the truth table faster. You only have to calculate the one line, not all of them. Now, in a certain way, this is a little bit counterintuitive, because in order to do this, you have to sort of think backwards. You have to think from where you want to get to, and then figure out how to get there. But we can do it. Let's take Consider this argument. A, therefore, if A, then B. That's pretty obviously not a valid argument. But if you were trying to fill out the whole truth table for it, well, you'd have to fill out 4 rows. Let's see if we can do it a little bit faster. Let's work on doing it in just 1 row. We start out putting out the truth table with the 1 row there. You know, you've got the A and B in the columns over to the left, and you've got the statement of the argument here over to the right. Now, what you want to do is you want to figure out a way for the conclusion to be false while the premise is true. Now, so we mark the conclusion, the error, the main connective in the conclusion, false. Now, how's that possible? It says, if A, then B. How can that be false? Well, there's actually only one way, and A, then B can be false. And that's for A to be true and B to be false. And so we do that. Now, if that's so, well, then our A over here has to be true also. And we can fill in the values over here. A is false. A is true, rather, I'm sorry. And B is false. Notice what we've done. We've established a line, a row of the truth table, where the premise is true, A is true, but the conclusion is false. So the argument is not valid. We only had to do a single line. What we had to do is we had to start at the end and reason backwards till we had the beginning. Now that, as I said, is a very easy case. You could probably tell that that was not a valid argument without even looking at the truth table. Let's take one that's a little more complicated. How about this one? Not A and B, not A, then C, or rather, if not A, then C, and if not B, then D. Therefore, C and D. That has a little bit of surface plausibility. It's also not a valid argument, and it'd certainly take you a good bit longer, because you'd need 4 different statement variables, 4 different atomic statements to do that, and that's going to take you, I think, 16 rows. Let's see if we can do it a little bit faster. We know we want the premises to be true and the conclusion false, so let's mark that. And you end up with something like this. Premises marked as true, conclusion marked as false. Things can go different ways here. Let's just experiment. Let's let both C and D in the conclusion be false. And then we end up with something that looks like this. But we can go a little bit further than this. If D is false, then if not B, then D is going to be true, then not B has to be false also. We don't want it to end up being not B being true, a true then false. That doesn't work for a material conditional. Not B is going to have to be false if D is false. We can say the same thing about C. If C is going to be false, then in order for not A, then if not A, then C to be true, not A is going to have to be false. So we get this. But we've reached a dead end. With A and B both being true, which we've marked over here, we can't make the first premise, not A and B, both be true. Time to go back to the drawing board and try something else. Let's suppose that C is true and D is false in the conclusion. Only one of them false and the other one true. And you get something like this. Now we work through it again. With D false, not B has to be false also. So you get this. Then, with C being true, not A has to be true also, so you get something that looks like this. And you've filled in the A, B, C, D in the columns over on the left, and we can use that to fill in the rest. And now the premises are all true and the conclusion is still false, so it's invalid. We've proven that this argument is not valid by showing that there's an assignment of truth values where the conclusion comes out false, but all the premises are true. But what about a valid argument? Let's take a look at a very simple one, our old friend modus tollens, that is, if A then B, not B, therefore not A. Of course, we just draw it out in the way that we're accustomed to, and you get something that looks like this. Now, we set it up in the same way. We're going to try to get the premises true and the conclusion false. Since the conclusion is not A, for that to be false, then A has to be true. And then we stick that in. For not B to be true, that's the second premise, B has to be false. But now, notice that we've run into a problem. In that first premise, it's no longer true. You can't have an if true, then false, and call that a true conditional. If A, then B, given the assumptions we've started with, where A is true and B is false, well, that'll be false. So, we mark that with a slash instead to indicate there's no truth value assignment that allows us to make the premises true and the conclusion false. That's how you detect a valid argument. Of course, there are more complicated cases. We'll take a look at one more complicated one. If x, then z. If y, then z. Not z, therefore x, if and only if y. We want the premises to be true and the conclusion to be false, as always. But there's two different ways for the conclusion to be false. So maybe what we should do is we should start out with two different rows. You remember, when you have a biconditional is true if they're both true, and it's also true if they're both false. And so if we want them to be false, we want one of them to be true, but not the other. And there are two different ways you can do that. You can have x true and y false, or you can have y true and x false. Anyhow, that's the idea that we're going to be working with. We start filling in. Of course, we want to leave the false in the conclusion, and with the values for x and y, and then we're going to go across the line and we're going to fill in where we want the premises to turn out to be true. We put a T under the if-then under if x then z, a T under the arrow if y then z, and a T under the tilde under not z. And then we fill in the x's and y's according to what they are in the conclusion. And you'll get a variety of things there. You'll get something that looks like this on the bottom. Add z in the last premise. You want not z to be true, and so z is going to have to be false. Then we fill in the z's down at the bottom of the screen there. And what do we get? Houston, we have a problem. The first premise in that first row has to be false rather than true with the given truth values. You end up with if x then z, where x is true and z is false. That's always going to be false. You run into the same problem with if y then z. Y will turn out to be true in that row, and z is false. So we can't have that be a true premise. In both cases, we substitute slashes, and that's it. We've covered all the possible ways that the conclusion can be false. And it turns out that if the conclusion is false, there's no way to fill in the premises with consistent set of truth values so that all the premises are true. And so the argument is valid. That's all there is to it. Now, this is, in a variety of ways, a little bit difficult, but, well, it beats doing 12 or 8 or 16 lines. It's a useful tool to think through it and figure it out. And now I'll leave you to more practice.